Good morning, good afternoon, good evening, everyone. Depends on where you are in the world. Welcome to MSC Software, the new webinar. Achieve highly efficient conceptual design of aerostructures using MSC Apex. My name is Zanlang. I'm the product marketing manager of MSC Apex, and please allow me to introduce you our presenter today, Larry Pierce. So Larry Pierce is a senior lead application engineer at MSC Software, and he got his bachelor and master degree in mechanical engineering from Auburn University. He has over 25 years of experience. Prior to joining MSC, Larry worked as a stress analyst using both Patron and Nastran. While at MSC Software, Larry has supported users of Patron, Nastran, SimExpert, and now he spends most of his time in supporting MSC Apex. If you have been using Patron for a while, Larry may be best known for his contribution to Patron Utilities menu. So please let me introduce you, Larry Pierce, and he will start the presentation very soon. So before he starts, I just want to remind people who just joined us, please help me to fill the polling session in the right part of your screen so that we can follow up and provide you the recordings and the PPT of today's webinar. Okay, thank you so much. So Larry, you have the ball.
Thank you, Zanlang, and you can hear me okay?
Yes, I can hear you clearly.
Okay, thank you. Great. Well, my name is Larry Pierce. I am excited to be here today to share with you about using MSC Apex for the conceptual design of your aircraft type structures. And to be honest with you, any structure that has a level of repetitivity to it, cargo ships, rockets, etc., could all benefit from the things that we'll talk about today. I see a lot of people's names on the call that I know, and so I will say it's good to see you virtually, and I see some names I don't know, and it's nice to meet you virtually as well. Maybe we can meet someday face-to-face. So let's talk about conceptual design of aerostructures using MSC Apex, and let's get started by talking about, some of the, let me do a click here. Let's get started by talking about some of the challenges that you might have when you're doing conceptual modeling. Now, MSC Apex, when it came out of the gate, it's been a tool that was really designed for faster CAD to mesh, effectively faster CAD to results. It's got a lot of functionality in terms of automatic model updates. We call that generative. And a lot of people that Apex has appealed to have been the people that were doing the detail modeling. They had solid geometry that was very rich, lots of detail, and they needed to idealize that quickly into maybe a mid-surface representation, right? So conceptual modeling people have the opposite problem. They don't have the solid that has all the detail. They've actually got the minimum of geometry. They've got an OML surface. My example in the picture here actually has cutouts, but they may not even have that. They've got datum planes for frames and bulkheads. They've got curves for stringers and such. So they don't have the detail, and they need to add some detail so that they can get the proper stiffness, so they can get the proper load distribution, so they can get the proper behavior of the structure so that they can run it and make some design decisions, right? Additionally, since you've got so little detail, conceptual modeling requires a great deal of engineering experience and knowledge, okay? In other words, how do I add the appropriate level of detail to get the response, to get the behavior that I'm after? Usually they're modeling the entire structure, so it's usually a coarser mesh, once again, mostly for load distribution, internal load distribution. They do have to apply, once again, a lot of experience and knowledge as to the level of detail that they're going to include. A good example might be frames on an aircraft. Do I initially model those as just a bar element? Perhaps I may actually want to model them to get a better representation of the behavior as perhaps shells, elements for webs, and maybe rod elements for flanges and such. Since it's a coarser mesh, and since there's not quite as much detail, a lot of times to get, once again, the proper stiffness and the proper behavior, there's a lot of idealization that goes on with the property data, adjusting thicknesses and cross-sectional areas and such, once again, to get the appropriate stiffness, to get the appropriate distribution of the loads. Most people who do this have some level of automation. And there are some people I know that probably feel that they've got this pegged, right? But a lot of the people that I talk to, They don't have it pegged. They have some level of automation, but they also have gaps and holes. They know that, yes, I can run this section automated, but then I have to kind of by hand piece that together with something else downstream. As a result, there's lower productivity in this area just because of the amount of effort that's required to make the model in the first place. And that's very key here, and that's why we're really talking today, is because at the conceptual design stage, you really want to look as many alternative designs as possible, because it's much cheaper to change at the conceptual modeling stage of the process rather than 2 to 3 years down the road figure out we should have done something better, right? It's much cheaper to find that out early in the process. So why MSC Apex for all this, right? And if you've listened to any of our webinars in the last few years, you know that MSC Apex is once again a tool which really helps you improve your CAD to mesh and your CAD to results process up to 10 times faster. And honestly, I've talked to a lot of folks that was much, much faster than that. This productivity is achieved by the innovative environment that MSC Apex offers. It's a direct modeling, direct model interaction with a generative technology, automatic model updates based on the direct interaction. This innovative environment actually makes Apex relatively easy to use and easy to learn. And you don't see this in a sentence with the word finite element very much, but many people say it's an enjoyable experience as well. And with the Iberian Links release of Apex recently, Apex is much more tightly coupled with the most trusted finite element software, which is, of course, MSC Nastran. So, as I have said, MSC Apex has always been a tool that offered you the ability to go from the CAD to the mesh and the CAD to results faster. It's all based on this innovative environment, this natural, intuitive, direct model interaction through edge and vertex drag and face push and pull. This really has appealed, once again, to people that are doing the detail models where they have to take some solid that's really rich and they want to get an idealized mid-surface rather rapidly. And they are leveraging all this direct modeling. They're leveraging all these automatic model updates. And the conceptual modeling folks look at this, and it's kind of like somebody's got some candy and you want to get some of it, right? So they say, I could use this too. And they absolutely, this direct model interaction applies to them as well. Although, once again, since they've got the minimum of geometry, they've got a few special needs. So we'll circle back to that in just a few minutes. Not only is MSC this Apex, this innovative environment for generating your model, it's also an innovative environment for just doing structural analysis, period. It's got a part in assembly data structure that lets you, inherit the data organization of CAD if you want to, or you can reorganize it. It's got some model checking features we call analysis readiness to make sure the model is ready to run rather than run it and get a fatal error message, kind of like shampoo, lather, rinse, repeat, run, fatal, right? Well, let's stop that. Let's fix that before we run it. And of course, with the Iberian Links release of Apex, we're tighter linked to MSC Nastran. Of course, Apex has got full-featured results exploration tools. And another feature that, once again, really appeals to all modeling, not just conceptual modeling, but the ability to extend what you can do in Apex, the ability to automate what you can do in Apex through the Python scripting API. An example for detail modeling might be automatic creation of fasteners, and I've written several scripts to do that. For the conceptual modeling crowd, it might be to take this minimum of geometry to add my engineering acumen, so to speak, to add the level of detail to the model that I want, and to do this, of course, in an automated and automatic fashion. So we want to talk about how Apex will help in the conceptual modeling area, how that will help you achieve that. And rather than go into a room and just develop some tools and hope somebody uses it, we've actually talked to people that want to do conceptual modeling with Apex, and we've asked them, what are the rough edges in your process that we can kind of help smooth out, and what are some features in Apex that you think we're missing that would really benefit you, that would make your process go much, much faster. And once again, the significance of faster at the conceptual modeling stage is it's much cheaper to redo the model there than it is 2 to 3 years later once you're in the process. So some of the things that we have done to kind of smooth out the rough edges and to make Apex more beneficial to people doing conceptual modeling, minimal geometry. The current direct modeling environment, the current generative environment plays well no matter what kind of geometry you have, whether it's feature rich or whether it's minimal. Mesh control. If you're doing a coarse grid mesh of the entire structure, you want to be able to control the mesh, right? Because you're going to have a coarser mesh. Most of these structures have stiffened panels with frames and stringers, so we want to look at some key features that have been added to Apex for that. Of course, idealization of the properties, and of course, automation, which is a key element here in order to do this much faster. All right, so let's kind of talk about each one of these and go forward. We'll do some demonstration, and we'll show some actual live scripts just a little bit later today. So as I said, a key element here is just the innovative environment that is MSC Apex. The direct model interaction, once again, appeals to users whether they're doing a very detailed model or whether they've got minimum of geometry and are going to add the level of detail later. Because once again, the ability to drag an edge, drag a vertex, and have everything else automatically update, that's pretty compelling no matter what level of model you are doing. Another key element in MSC Apex for conceptual design is just the data structure that's in Apex itself. Once again, this is really key because I can inherit the data organization from the CAD system, or I can go off and do my own thing. In MSC Apex, the parts and assemblies are just like the physical parts and assemblies. They're separate from one another, okay? So in order to maintain this separateness, but yet also connect them together for a monolithic finite element model, a key capability in Apex is something we call edge ties. And you can see here you can see on the left image here that I've actually got a rib, and I've got a rib, and I've got an upper and lower skin. And you can see that the meshes do not match, okay? That's not going to be good from a finite element perspective because I have a non-congruent, non-connected mesh. But what I will do in Apex is I will apply an edge tie. And that tells Apex that these parts are actually connected. So now I get a congruent and connected mesh, but I've maintained the data structure that I had originally. I've not changed that. There's some additional benefits to this as well. Imagine having a rib on the wing and you tied it, but you'd kind of like to move it. In other words, I've done my conceptual design model, but now I want to tweak it a little bit. I think if I move a rib, it'll be better. Or as seen in the animation that just played, maybe I want to copy a rib to make things better. That's really just leveraging Apex's direct modeling and generative capabilities, yet I'm doing it on a conceptual model. Once again, in this example, when I did the edge tie and then transformed the rib, the edge tie came along for free, and the model automatically updated for free as well. And I'll illustrate that in the demonstration as well a little bit later. Another key capability is mesh control. If you're going to have a coarser mesh, you really do want the mesh to be the way you want the mesh to be. Okay, that sounds like an oxymoronic statement, but it is true. Oftentimes, these structures, there's a lot of repetitivity to the structure, so you really do want a well-organized mesh that looks with a lot of square and perpendicular elements. But one of the things that always happens, as seen in this little wing example in the upper right, there's always going to be areas where you have to put a triangle. And what I've seen in many people that are doing conceptual modeling is they're retentive about the mesh. They either want the triangle to break to the left or break to the right. And so in order to allow people to have that level of control, which we've got other mesh control mechanisms in MSC Apex. I mean, it could be edge mesh seeds, for instance, but the mesh control curve is kind of like the granddaddy controller of all times, right? Because I can actually impose my will on the mesh and get the mesher to follow this edge the way that I want to, so that in the case of a wing with stringer runout, I can break the triangle left or right. It doesn't really matter. Another example might be the cutout in a fuselage. So there's a hole where there's going to be a window. A lot of times in the curved areas of the hole, you might actually want a triangle there oriented a particular way, and mesh control curves allow you to achieve that very easily. I will demonstrate that as well in a few minutes as well. Okay. Lastly, most of these structures are really stiffened panels. Okay. The kind of stiffener that's used depends upon who's making the model and what kind of behavior they're expecting from this model and what kind of stiffness they're expecting from this model. And so some people will choose to model the stiffeners maybe with just a beam element. Maybe it's just going to be a stringer that's a beam element. Some people will choose to just enter in area and inertia data. A lot of times that may not actually be formally known. You know, we're just kind of guessing or kind of basing it off of past models that we have made. But you may also want to kind of go up a level of detail. In other words, after I've used the beam element, perhaps as in the lower images, maybe I want to use a web that is a shell element for shear, and I want to use a flange. I want to use a rod to represent the flange, because the flange at my level of modeling is just going to go with tension or compression at this point. We're actually beginning to encroach on a internal loads model at this point, to be honest with you, but even at a conceptual modeling stage, I may need to go up just one level to get the proper behavior that I'm after. Okay, and we'll look at that and see how the new 1D profile in MSC Apex makes the modeling of a frame with a little more detail than just a beam element actually feel like you're just doing a beam element. And of course, the star of the show here, in addition to being just the innovative environment that is MSC Apex, the key here is all of these functionalities that I've shared here. They're all good in and of themselves, but they really shine if I can automate them, right? Because then I can do my entire model in an automatic fashion, and we'll illustrate that as well. So let's do a demonstration. I want to just show you by hand how some of these capabilities work, and then we'll actually go on and talk a little bit more about the API in Apex, and we'll talk a little bit more about how to write a script for some of these things. Okay? All right, so the first thing I want to illustrate is I want to illustrate the edge tie concept. So here I've got a very simple wing that actually, in this particular example, my wing has got some spars. It's actually got some ribs. You can see the ribs. You can see the upper and the lower skin. And yes, it is a kind of a simple example, but I just want to illustrate the concept. The concept works equally well, even if something a little bit more difficult. You can see at this point that, you know, my nodes are not lined up, so I've effectively just got independent little finite element models. I can actually validate that in Apex by turning on some edges here so that I can actually see a red edge means it's a free edge. So I can see a lot of red around the ribs, so I know that it's not connected to the skin. We'll go ahead and keep those on. So let's go and do our mesh tie now, our edge tie. Okay, so I'm actually going to zoom out so we can see a little bit more of the wing. And what's really cool about this is I can just drag box the whole thing. And thinking ahead to being able to do this in a script, that's very convenient, because although Apex has got scripting functions that lets me know where I'm at and lets me know who I am close to, the ability to just sort of drag box the model and automatically let Apex figure out what's going to be tied in this case and what's not going to be tied, that's really, really convenient. You can see that my colors here have changed. I got a little marker that indicates there's a tie. You can see that we've got a yellow color there now, which means that it's no longer a free edge, that it's actually tied to the skin. So I've got that monolithic congruent type mesh going for me. Once again, the key thing here is not only the ease of creating these, but the additional key is just the ability to work with this, because maybe I have gone through the process, I have made my conceptual model, and now I would like to just tweak it. I'm not making drastic changes. We just think if we move this rib over, life's going to be better, okay? So once again, the tie automatically updates. This is really leveraging the generative capability in Apex. And if I think I need another rib, well, I'll make a copy. And when I make a copy, that tie is automatically there as well, right? So I've made some changes. Normally this would have been a lot of work, right? This was really, really quite simple in MSC Apex. And I know what you're thinking now. You're saying, okay, well, Larry, you did this on the easy part of the wing. What about this part of the wing out here where there's some changes in the orientation of things? It's probably not going to work quite as well there. And the answer is actually true, okay? So, just full disclosure. And the reason is because the ties are applied with some kind of tolerance, right? So it is possible that you can move this guy and he's no longer in tolerance, which means I've now broken the tie. Not a big deal in Apex though. Once again, remember it's direct modeling, remember it's generative, so I can just easily make sure those edges make sure these edges are on my surface, okay? Make sure the edges are on my surface and just simply go back to the tie and just retie. Okay, and this is not only is this easily to do interactively, but this is actually easy to do programmatically as well, to detect this and to know that you need to actually, Apex will actually let you know when things are broken. Okay, so let's go look at another example. So let's show another example here. And this time, I'm not going to be talking about edge ties. This time, I actually want to be talking about those mesh control curves. Looking at the mesh control curve. So here I've got a wing. It's a pretty simple representation, but it works really nicely. You can see that on my wing, I've actually got some stringer run out right here at the rib intersection, and I've already created a couple of curves that I'm going to use as mesh control curves. So let's go in and mesh this now, and we'll just simply choose that surface. And you can see the black edge there. You can see that, well, that's not exactly the mesh that I may have wanted. All right, let's do another area here. Once again, I get the mesh, and I want you to know there's other ways that I could correct this. Okay, I could adjust some mesh parameters perhaps. I could also use some mesh seeding perhaps. But the key thing here is the mesh control curve, because I don't have to get, if I'm using a different mesh control parameter, I might be guessing just a little bit. But with the mesh control curves, I'm not guessing. I know exactly what I'm going to get when I'm finished. So let's come in. I'm actually going to select this curve, and I'm going to select this curve. I'm going to break left, and I'm going to break right, and then I'll pick my two surfaces. And MSC Apex has updated the mesh. You can see we put a little marker to indicate this is a mesh control curve. If I hide the curves now, I can see that I've got a mesh that's exactly what I want, and I can see that I've got the triangle located exactly the way that I wanted the triangle located. Okay, so the ultimate in control for the people that are most retentive about their meshes, and I think that's an excellent capability. The other thing about the mesh control curves is I could have achieved this by splitting the surface as well. But when I split the surface, now I've actually got multiple faces on the surface. There's some advantages to not having multiple faces on the surface, simply because now I can still reference that surface as just the surface, right? And that might make it easier for the application of element properties or even loads or boundary conditions. Let's look at another example, okay? And this is actually a little fuselage section with some cutouts in the wing, okay? And let's actually go ahead and hide the areas that are going to be the frames. And what I want to do here is I want to control the mesh around the windows. So if I look at these curves that I have created, these are the curves that I'm going to use to control the mesh, okay? And this is, once again, when you think about doing this programmatically, when I'm doing this interactively, my mind is engaged, right? And I'm visually picking the things that I want to pick. How am I going to do that programmatically? Once again, when we get to talking about the API, MSC Apex has got some great features to help you find things and find things that are close to each other. But Apex has also just got some awesome capabilities that says, okay, I'll figure it out. So I'm just going to drag box. I'm going to pick all the curves, and I'm going to pick all the surfaces. And Apex automatically figured out which curves go with which surfaces. And I will get the mesh control curves where I want the mesh control curves, okay? And I actually, and let's try that one more time. I will get the curves where I want the curves so that I can control the mesh the way that I want to control the mesh, okay? And we've kind of highlighted that previously. I think it's not doing exactly what I was expecting at this point, so I'll apologize about that. So let's go to our next example. And the next example I want to illustrate the stiffened panel capability that's in Apex. All right. So I'm going to come in here now, and I want to start out by creating a frame that's just going to be a bar element. And I'm just going to use an L section, and the L section, I'm mostly using it for visual effect, but it could be this section or it could be another section. Going to make it 2 inches wide on the flange. I'm going to make it 7 inches height, and I'm just going to give it a thickness of 0.1 and give it another thickness of 0.1 as well. Okay, so that's going to be the section that I'm going to use. I'm now going to go and create the beam span. All right. Normally, when you create a beam, you might think about, I'm going to define the orientation myself. That would be like a light pole, right? In this case, I actually want to orient the beam, and I want to apply the offset based on the geometry to which it's applied. So we would call this a stiffened panel. And Apex gives you a nice little graphic here that kind of shows you what the orientation is going to look like. So I just click a few buttons, and I can see that now I'm oriented properly with respect to the bottom side of my surface. So I will select the curve, I will select the surface, and there is my beam section. And once again, the orientation and the offset is based on the surface that I have selected. And also notice that this could be tapered as well. So I can define this section in 2 different dimensions, and Apex will automatically taper from end A to end B for me. Okay, so that's one level of applying a stiffener to a panel. Let's look at another level of doing that, and we're going to do that with the 1D profile. All right, and so for the 1D profile, what I want to do in this case is I'm going to do 2 different examples of this, and the first example is going to be, for instance, a web with rod elements as the as representing the flanges. So I'm just going to come in here and I'm going to create a curve that's going to represent the web. Okay, and I'm just going to say that it's 7 inches tall, and I'm actually going to create an additional curve to be the web, and I'll just say that it's 4 inches tall. And the reason I made 2 separate curves is I actually want to have a flange at 7 inches and I want a flange at 11 inches in this example. Because I want the person who follows me to understand what I have done, I get to annotate this. I get to, tell the user that, hey, this is the upper and lower web. So I get to annotate it. That's really good for the next guy that comes along that needs to do this. Let's save this, and let's call this web and rod. Okay, so we'll call it web and rod, and we'll save this guy. And now we will enter in, because this is actually going to be shell elements in the web area, I get to enter in a thickness for those values. All right, we will close it up, and we will now create a span. So this is exactly the same as if I'm creating a beam in MSC Apex. Okay, I just double check to make sure that it's oriented properly the way I want. I will select the curve, I will select the surface, and there is my representation of the frame, except this time it's going to be represented with shell elements. Now I want to actually create some rod elements to represent the flange part. So I will say that I want to create a numeric shape, and that numeric shape will be a rod, and I'll just enter in an arbitrary area value because this is just a demonstration. I will now go to create the span, okay, and when I create the span, I'm just simply going to select this edge and this other edge. All right, so now I've got a shell, which is going to be the web of this frame, and I've got rod elements here that represent the flanges, and I can actually mesh this, right, because this is now part of my model. So let's say we want to use 20-inch elements on the shells, okay. So there are those elements, and I will also create a mesh for the rod. So I've now created a finite element model representation of the frame in this case. And this could be using a shear element if I just wanted this to be shear, or it can be a shell element as well. Let's do this one more time. Okay, let's do this one more time. And this time we're going to create the 1D profile again, but we're going to add the next level of detail. Okay, so we will create for ourselves a web area, and let's just make it 8 inches tall. And let's kind of zoom in a little bit. And now I will create the flange, and I'll just say that it's going to be 2 inches. And I'll actually just come in here and create an additional flange, and we'll just say that it's 1.5 inches. Okay, so I could go ahead and annotate this for the future, but since it's just a demonstration, I will pass on this at the minute, and I'll just call this all shells, and I'll save this profile. And now we'll go back to my model, and I can enter in my thicknesses because this is going to be a shell. All right, and you can see that this works really well, but ultimately I really do want to automate this, right? And this is completely automatable in MSC Apex. So I will apply this as a stiffener to the existing OML, and I will simply say this curve, this surface, and Apex automatically builds for me a frame that will be a shell or shear element representation in this case. And this is easy to do interactively. It's also really easy to do programmatically. And I can say that with all honesty because I have done it. Okay? So I wouldn't send you off to do something that I myself haven't tried first. Okay? Let's go back to the presentation now. And let's talk about the scripting API that's available in MSC Apex. And there's a few animations that are going here, so while I'm talking, you can kind of look at them. One is creating some fasteners automatically. One is creating some geometry of like a bellows automatically. And then the one in the bottom is actually making a simple buckling model and doing the buckling solution and post-processing automatically. So there's a lot of things going on here. But a key to the API that's part of Apex is Apex itself, that innovative environment. All the things you can do in the user interface, even those interactive activities such as edge and vertex drag, are all scriptable. Okay, that's a really cool feature that I find. The API in Apex is Python-based. This is sort of natural since Apex itself is object-oriented, and of course Python is object-oriented as well. You do not have to be a Python expert because I'm not a Python expert. I do think it's beneficial to kind of know a little bit about lists and dictionaries because that can help you. It's not a requirement, but that can help you organize data as you're writing your script. Of course, being Python-based also gives you direct access to a lot of modules that are out there, whether it be interfacing with Microsoft Excel or whether it actually be perhaps using something like NumPy if you want to actually do some in-depth mathematical calculations. On top of Apex being based on Python, there's a certain, I like to call it richness of the API. And part of that richness is just the object-oriented nature of Apex itself. Every object knows his name, knows where he's at, knows who he's connected to exactly. So that's a certain richness that's in the API. The API also has a lot of functions for what we call introspection. Another word might be query the database. In other words, what is your area? What is your midpoint location? All sorts of functions that help you interrogate the model. And once again, if I'm doing it interactively, my mind and my eyes are in the loop, right? But if I'm doing it programmatically, I got to have some extra information so I can make decisions about what to connect together and how. And lastly, in the richness area is a search capability. This is very invaluable because it just simply allows me to take an object, be it a point, a curve, an element, a node, and ask the question, who am I close to? And that's really beneficial if you're going to connect things together. It's beneficial for mesh control. And as illustrated in the example on fastener modeling, that's obviously a very key element of that as well, being able to locate holes that are close to one another. And all of the API in Apex is fully documented. The documentation is very hyperlinked and cross-linked. It's honestly easy to navigate. But the way that a lot of people will do it, including myself, is macro record replay. I will simply record a quick macro of me doing something, and then I will stick that into my script that I'm writing to do what I want to do. And it's very easy to do that and saves you looking in the documentation. So let's look at a couple of examples. We're going to look at a wing example, and we're going to look at a fuselage example. And the scripts that I have written, they're real in the sense that, hey, they actually work on a lot of different geometry types. I've actually got several different wing variations and things like that, and the scripts work. And the thing that you do when you write a script like this is you have to ask yourself the question, what is I want to do with a stringer? You know, how am I going to mesh it? How am I going to represent it? What am I going to do with ribs? And am I going to include the flanges on the ribs and spars and skin? So you have to ask yourself these questions, right? How am I going to identify them? Am I going to identify them by location in the model? Apex will let you do that. Or maybe I'm going to locate them by the name that comes in from the CAD system. Apex lets you do that as well. A key element is how you're going to mesh it, and the mesh connectivity and the mesh control. Apex has got you covered there. Applying the properties, which once again are highly idealized. Those could come from a spreadsheet or other mechanisms, loads and boundary conditions, etc. And honestly, it's the same list whether you're doing a wing or whether you're doing a fuselage. So let's look at an example of that. So I'm going to start off with the wing, okay? So I just have a script here that does a generic wing. I get to pick like what kind of shape I want for my stringers, and then I simply get to pick the geometry file that I want to use, right? So this would be like perhaps the CAD file that I want to process today. And I hit the green check, and Apex is off and running. And what my script is doing is it's locating the stringers, it's locating the ribs, it's locating all the different pieces of geometry. For the stringers, I'm actually creating beam elements. So here you see those beam elements being created. And not only are they beam elements, but they're tapered. So it tapers from the fuselage out to the tip of the wing, and that was just my decision. You could do whatever is your structure. I just chose to do that for mine. Next, the script is actually taking all the pieces of the model and actually using the edge tie capability that I illustrated earlier to actually tie all the ribs and all the stringers, and you can see all the markers now for the ties. Now it's going through and it's actually identifying regions of the model, and in this case, it's applying the mesh control features that I want to get the mesh that I want in those areas. And the little scroll bar that's popping up now is actually I'm going back to each one of the areas and I'm kind of checking what the mesh is in that area, and I'm making a decision. Maybe I want to update that mesh to improve the mesh. The script is actually finished now. It's actually just showing us different pieces of the model. We can look at a log file. I just included some information about how many elements were created, and I can see that this only took a minute. So that's pretty good. And I can now come in and just highlight just a few features here. Once again, if I turn on edge ties, everything is tied. So everything is independent parts just as it came in from the CAD system. I can actually, let's look at some of my stringers now, all right? And if I get the right view, you can sort of see in this case that the stringers are actually tapered. It's actually a greater depth here than it is down here at the wing tip. All right. I can actually kind of validate that by selecting on one of these, and I can see that over this span, it's a slight taper. It kind of shows up a little bit there, not dramatic, but a slight taper over that region. I can look at the ribs if I want to, so we'll just show the ribs. Now, I know that real ribs have some flanges on them. I chose not to include that. I know that you might want your mesh on your ribs to look differently. This worked for me, but we can control the mesh to get the kind of mesh that you want, and absolutely can include flanges. That would be just as simple as adding the stringer in most cases. For the skin, I know that I wanted to control the mesh on the skin, and you can see that I've got really nice mesh where I have stringer run out. I got a triangle. I have it going in the direction that I want that to go. I assigned a 2D orthotropic material property, and I've actually defined material orientation. This particular model is actually run ready. Okay, I've actually got a down bending load, and all I have to do is just simply go to place it in an analysis scene. I can either run it directly in Apex, or I can simply come up here and I can just say export and run it in Nastran and then post-process it in Apex if I want to. So I have all of that available at my disposal. So this is actually ready to go. Okay, let's actually look at a fuselage section as well. All right, so once again, I've just got a script here, and I'm not going to show you all the lines of the code. It's actually not very much, but I get to choose how I want to represent the frames, whether I want to use a beam element, shell for the web, and rod for the flanges, or shell for both the web and the flanges. I'm just going to, in this case, just choose the beam, but it works either way. We'll just pick a subset of the model, and we'll just go off and run. Okay, so it's creating the stringers now. It'll be creating the frames in just a moment. Then it's going to mesh everything. I apply a few fake boundary conditions, and I put a pressure on it. Obviously, I could do much, much more. This is just a subset of the fuselage. The whole fuselage only takes about 2 minutes. This subset will take less than 30 seconds. So that's one reason I'm just going to illustrate that today. I'll be happy to share my models and share my scripts if people are interested in investigating this with MSC Apex. And once again, if I go in and I can go in and look at these mesh control curves, and we can see that. Let me hide the skin here. So you can see that I've really got the mesh that I wanted. I wanted the triangles and the round areas, and it was the mesh control curves that let me accomplish that. You can see the little markers where all the mesh control curves are here. Okay, so actually a really nice mesh in that case. So anybody on the call who's done conceptual modeling, they know that once you get the model, you're really not done, right? You do need to run it with Nastran. Apex will export this for Nastran, and we'll also do some checks on the model for you. You can run it with Nastran, and Apex will post-process the HDF5 results file. For this level of model, you're obviously not looking at stresses, okay? But you're looking more for how the external load that was applied, how the stiffness and behavior of the structure has distributed the internal load distribution, right? One way that you would do that with Nastran is, of course, maybe monitor points. Apex has actually got a mesh-independent version of that. We call it the cross-section sensor. The cross-section sensor will actually, unlike a monitor point, which you have to specifically enter in the nodes, the cross-section sensor is mesh-independent, so I can cut across elements to get the shear bending moment torque anywhere I want in the model. And I can actually add these after the model has been run. I don't actually have to have these in the model when the model is run. I can add them on the fly if I think there's an area of the model that I didn't think I was going to ask for data, but I think I need to see it, and I can add those on the fly later. Okay? And once you get the results, you're honestly still not done, because remember, if I can do this quick enough, right, I can go through a lot of different design scenarios, which will save me money versus making some kind of change or some kind of localized redesign 2 to 3 years down the road. So one of the things I see when I talk to people about this, I know they want to put some optimization in the loop, maybe to observe best places to put ribs and spars and stringers. One way that that process might look is I bring the geometry out of CAD, I come into Apex, I apply my script that creates the more detailed model from the minimum of geometry, run that with Nastran. I can do some level of optimization with Nastran, maybe some sizing optimization in some areas, but I could also have a big loop optimization where I'm actually considering different design updates on rib locations and stringer locations. That information might best go back into CAD, but then I come right back into Apex, run my script again. I can do this loop many, many times and look at several different alternative designs very early on in the process. Another way that this might look is that I bring the geometry into Apex. I run my script, I run it with Nastran, and maybe I just want to look at some local design changes without going back to CAD. This is where Apex's generative capabilities come in. Once again, if the ribs are tied to the wing, I can use a transform and move it over and update those ties really easily without having to go all the way back to CAD before I decide what kind of changes will be most beneficial to our design. So I hope you've enjoyed today's presentation. I hope you see that, versus what many people are doing today, not everybody, but what many people are doing today, there are gaps, there are holes. And I think that through the features that I've highlighted today with MSC Apex, many of those gaps and many of those holes are closed. And you really will be able to do this much faster than you may have ever done it before. So I thank you for your attention. I appreciate that actually a lot. And if there are questions, while we're answering questions, we've got an animation that shows the wing being generated on a more complicated wing. And it's the same script. It's the same script that I used on the simple wing, and this is a much more difficult wing. Okay? So Zanlang, are there any questions?
Yes. I just see one question. So people on the floor, if you have any questions for Larry, please submit your questions in the Q&A session so that I can read out and Larry can explain for you. So Larry, I got one problem from Jaron. He asked, is MSC Apex available for personal use for self-training?
So that's a very good question. If you're a student, you can get it for free, okay? You just go to our website and go through the right choices, and you can get the student version for free. If you are if you would like to be a customer and you can actually sign up for an evaluation, a 30-day evaluation. You can once again do that on our website as well. And that's a really good way to learn how to use the software, honestly, if you don't know how to use it. Because when you're doing an evaluation, technically you're not supposed to do real work, although that's the best way to evaluate in many cases. But it's also a good opportunity to learn. Yes. Any other questions?
I didn't see any more questions coming up. Probably people are still typing up. So I just want to add one point to the last question. So we have a free trial available for you to apply. So you can just Google MSC Apex free trial, and then you can fill in the form and get the free trial very soon. So although this is a 30 days free trial, but give you enough time to evaluate and follow the tutorial to know how Apex works and what's the new functionality are. So this is very convenient. So people to try. Yeah.
Any other questions, Zanlang? I have a question if nobody else does.
Sorry.
So any questions, Zanlang?
Yeah, I can see that. Oh, let me read it for you. So, is it possible to give connections between two 3D meshes?
Sure, I can do connections between different meshes. I could connect them with perhaps Nastran glue. I could perhaps connect them with RBE2s and RBE3s as well. So I have a lot of options available to connect meshes, 3D meshes together. Yes.
Okay. Another question is, can I get a copy of today's presentation and associated model files?
I'm happy to share. Sure. And I think the webinar has been recorded, and I think the presentation will be available in PDF version. So.
Yes, for sure. Yeah, we can share it out later. So, but our system, it takes a while to precise the video for us. It's a logistic issue, so we'll share out once it's ready. And another question is like mid-surfacing capability is great. So, are there plans to add beam extraction from solid?
That is in the roadmap. I don't think it's coming up in the next release, but it is absolutely something that we are aware of. Yes, and we will add that. I just can't tell you when. So.
Yeah, it's just a roadmap, right? Okay. Let me see another question. Okay. How to receive the MSC written scripts?
So how to get scripts from MSC. So you can contact me and I can hook you up. We do have a repository where people like myself are putting our scripts, and we can absolutely get you hooked up where you can download the scripts that are available. Yes.
Okay. I think another question is like, is there video or presentation available? Yes, we'll share out the videos, presentations, and also the models you will need to play around with later once the videos are ready from the system. Okay, another question is dynamic analysis possible within MSC Apex?
So within MSC Apex, we do normal modes and frequency response. That's with the internal solver. Of course, you can export the model out and do anything that Nastran can do as well. So yes.
Yeah. Okay, I think that's all the questions. So if any more questions on the floor, please let me know, and I will read out for you. So if you don't have any questions, please help us to fill the polling session. So it just take you 20 seconds to finish. So we are happy to hear more voices. Please let us know if you have questions. Let me check. Oh, I see some questions coming up. Yeah, I do have. Okay. Okay. There is possibility to directly modify solid meshes geometry to avoid further CAD or model modifications within the model file.
To be honest, I don't quite understand that question. I may need some more clarification. So I'll be glad to talk to the person directly.
It's from Jose Pimentel. Pimentel, probably you know.
Yeah. I don't recognize the name, but I'm not 100% sure about exactly what he's asking, so I'll be happy to talk to him directly, and then we can answer that question.
Yeah,
sure.
We have his contact so that we can reach out. Jose, no worries, we'll come back to you later. And then another question is, are there any plans in the future of Apex to incorporate more finite control of the exported Nastran BDF deck?
You can expect to see stuff in that area. I don't know any particulars on that, but Apex has always written out a Nastran bulk data file, but that was greatly improved in the Iberian Links release, a much tighter integration between Apex and Nastran, and that was just step one. Okay, so there's more steps coming, so you can expect to see more in that area. And if you have some detail that you're really interested in, please reach out to us and let us know, because we can't do it if we don't know, right? So if we don't know that this is a requirement, if you let us know what the requirements are, then we absolutely can try to work that in to the schedule.
Cool. And another question is, can we pre-process solution 200 in MSC Apex?
Not today. Apex supports 101, 103, 105, and 111. But you could easily set up optimization outside of Apex. You could even set up optimization with a script. Apex has the ability that when you export the bulk data file, you can trigger a script that will then modify that file if you want to. So you could either do it via a script that you wrote in Apex, or you could do it just outside of Apex, perhaps in Patran or another tool.
Okay. Another question is, can you use Apex cross-section result analyzer on any legacy model, even if not created in the Apex?
The answer is yes. It just needs to be run in Nastran, okay, or run in Apex. But the model does not have to originally be created in Apex, no.
Okay. And how do edge ties transfer loads between components if it's like, is it like an RBE?
So that's a good question. So internally, it's a zero length R bar, okay? You can choose if you want to, once you get out, if you want to remove the R bars and just create an equivalenced mesh, you can do that as well. But it's a zero length R bar. So.
Okay. Oh, so another question is like, is there a demo trial version for MSC Apex? Yes, there is a free trial. So you can just Google MSC Apex spray trail, and it will bring you into the page. You just need to fill in a little bit of questions, and our people will follow up and send you the link and the license. So it's a 30-day spray trail that feel free to use all the functionalities coming out in the latest release. Okay. I see more questions. So how do edge ties compare to other connection topologies, such as with RBEs? I think you just mentioned that question.
I mean, when it comes to connect, so an edge tie in Apex guarantees that you have a one-to-one node-to-node between the two parts. So in addition to connecting, it is actually making sure the mesh is congruent, and then the connection internally is with a zero-length R bar. So that's what it is. If I wanted to use a different element, such as RBE2s or 3s, I absolutely can do that. I mean, one advantage of like an RBE2 or 3 is that I don't have to have a one-to-one correspondence of nodes, and perhaps in the model that you're doing, perhaps there's benefit to that. So that's up to the user and to the kind of model that he's trying to create. But we have the capability of doing either.
Okay, one more question. Is it a plan to integrate aeroelastic Nastran solution into Apex?
That I don't know the answer to. We'll have to check with product design and product development. So I don't know the answer to that.
Yes, yeah, we haven't heard anything about that. Another question is, does Apex cover all the capabilities of Patran?
It's actually very close. In terms of geometry and meshing, the answer is absolutely yes. Matter of fact, it goes well beyond what I can do in Patran. I mean, the Apex environment for doing direct model interaction, the Apex environment for interactive, automatic model updates is honestly different and offers a lot of advantages versus Patran, which is more stagnant. You, the user, are initiating the update. With the Iberian Links release of Apex, we added the ability to do sweeps and revolves and lofted surfaces. Those were 3 geometry operations that were missing from Apex. And so now, once again, I think from a geometry meshing perspective, Apex is well beyond Patran in those areas. In terms of building a finite element model, there are still a few things that Patran can do that, for instance, Apex cannot do. There was a question earlier about setting up a Solution 200 optimization job. Well, Apex doesn't do that yet, right? But Patran does. So we're really getting close, but we're not 100% there yet.
Okay, cool. I think Jose just explains his question. So I think basically he's asking that whether modify the mesh to directly adapt to a future geometry modification without remeshing the whole model available in Apex. I think that's about generative direct modeling stuff. So for example, if a local fillet updates in a shaft, so the mesh will be updated as well automatically. So that's the whole idea about generative modeling capacity in Apex. I think my understanding for Jose's question is correct. So yeah, I think that's his question. And one more is like, how good will the PVM be from the free body in Apex if the section cut is not aligned with the mesh nodes or elements?
So I think this is a question about the cross-section sensor, and the cross-section sensor is actually using grid point force balance data to do that. And so I may not fully understand the question as it's being asked, but as far as I know, I mean, the number will be just as valid as any number that you get with monitor point or any number that you might do using Patran's free body interface plot. I mean, basically, Apex, if you cut through the element, we find the nodes on either side of the cut and then use that information to figure out what the data. I mean, we're just doing simple sum of forces and moments, right? To figure out what is the summation at the cross-section sensor. So.
Okay. Another question is adaptive 3D mesh possible with the control over error rate?
I'm not quite sure I understand that question either. So.
Okay, so probably we'll go back and check with Augustine about this question. Okay, are there any plans to incorporate solution 400 into Apex?
Just stay tuned. I mean, it's not here today, of course, but obviously we want to include nonlinear capability and nonlinear model setup in Apex as well. So just kind of hang with us. So definitely on the roadmap. So.
Okay, cool. I think that's all the questions I have already got. So yeah, thanks, Larry. I think that's all the questions.
Hey, thank you, Zanlang, and thank you, folks, for attending. I hope you got some information that you can use, and I look forward to trying this. So.
Okay, and for people, we don't quite understand your questions, so we will share out the product marketing email or also Larry's email. So if you have more detailed questions, please email to Larry directly so that he can explain details to you. All right. Thank you everybody for coming to our webinar, and thank you for your attention. I appreciate that. So yeah, I will see you in next webinar. Thank you, Larry. Thank you, William.
Thank you.
Thank you.